And we are going to go ahead and multiply fractions, which you've done in the past. We're going to give you a basic one just to refresh your memory on what gets simpler. To work it, we do not need a common denominator. We just multiply straight across. But if we can simplify it from the beginning, it will make life so much easier. So we look diagonally and decide, is there anything that will go into both of these two? 3 will go into both 9 and 3. So 3 divided by 3 is 1. 9 divided by 3 is 3. Will anything go into both 8 and 10? 2. 8 divided by 2 is 4. 10 divided by 2 is 5. Now we can multiply straight across. 4 times 1 is 4. 3 times 5 is 15. It will say, the directions will say multiply, and put your answers in the simplest form. If you can reduce from the beginning, your answer should be in simplest form when we've done. It's possible, maybe not. But if we multiply straight across, then we have to do a larger multiplication, more difficult multiplication, but also then reduce. So an example, we'll start getting a little bit more difficult here. We'll add in variables. So we have 6x or y cubed times y squared over 15. And if we can simplify from the beginning, that would make life so much easier. So let's look here. These two, they do, this one only has x, but both of these could be divided by 3. So 6x divided by 3 would give us 2x. 15 divided by 3 is 5. Sometimes as we get more and more involved, if you want to circle those, that way you don't lose the part. It is easy to lose variables. Now, what's common in these two things? Y squared. We go with the one that's the smallest power. So y squared divided by y squared, we cancel it out and just leave us with 1. Now, if we took y cubed and divided by y squared, what do we do with our powers when we divide? Subtract. So we get 3 minus 2 is just y to the first, or just y. So now on the top, we have 2x times 1, which is 2x. 5 times y, which is 5y. Once you get to this point, look at your answer and decide, can I simplify anymore? Nothing will go into both 2 and 5. Nothing will go into x and y. So that is our simplified answer. Okay, obviously, we've been factoring, so we're probably going to have to do some factoring. What I recommend on these, we have x squared minus x minus 12 over x squared minus 5x times x squared minus 25 over x plus 3. So we want to work on each section individually, one at a time, before we start worrying about any simplifying. So going back to yesterday, this is simplified, so let's put it in parentheses. Okay, that part's done. Now let's come up here and look. Factors of 12 that subtract to be negative 1. So 3 minus 4. What's 3 minus 4 is? Negative 1. 3 times negative 4 is negative 12. So we could rewrite this as x plus 3, x minus 4. So this part's now here. Okay. Different. No, we have, this one's not a difference of squares, but is there anything common in both parts? Okay. X. So we could take out an x, and we'd be left with x minus 5. So we took x out of both parts. This one now is our difference of 2 squares. We have x and 5. Remember, one of them is plus, one of them is minus. So this is now simplified. So if we want to rewrite it, you don't have to, but if you want to rewrite it to keep everything straight. So basically, I've just kind of put everything together. You could do the same back from over there though. Now, we have an x plus 3 here on the top. We have an x plus 3 on the bottom. Anything divided by itself cancels out. X plus or minus 4, we don't have anywhere else, but we do have this x minus 5. That's the same here and here. So now we look at x plus 5, there aren't any more, and there aren't any more x's. So on the top, we're left with these two factors, x minus 4 and x plus 5. And on the bottom, the only thing we're left with is just an x. And we cannot, again, take our x and simplify one of these because this whole thing is x plus 5. That's why the parentheses help us kind of keep them straight. Since none of these will cancel, that's our answer. So again, the key on all these today is factoring every single part and then deciding if we can cancel any like terms out. All right, one last couple examples we're going to do. We have done a little bit like this before, I think, but it's been a while. So if we have a power to a, we have a quotient to a power. Let's go back to, I'll show you. We take that power and give it to both parts. So we rewrite our answer as x cubed over 3 cubed, which is 27. So simplified, it would be x cubed over 27. Let's do one more problem we'll use in that. So now we're going to use that power, but we're also going to multiply it by another fraction. So originally, I'm going to put the negative back where they had it. So we have our power, c squared, 2 squared. But if we took what numbers between this negative and this fraction or a 1? So basically, we also have negative 1 squared. What is negative 1 times negative 1? Positive 1. So it kind of just goes away. So now we're left with c squared over 4. We bring this down. 4 over 3c. Notice our 4s will cancel diagonally. C will go into both of these. So if we divide this by c, we get 3. What's c squared divided by c? C. So we're left with c on the top and 3 on the bottom. Okay. So a lot of this today, the more basic ones, you're looking at little individual parts. The harder ones are when you have to start factoring every single part. And so I want to do a little bit of several of these today. So 9 to 19 on, 25 and 27, and then 35 to 41 odd. This is on page, I'm going to change that. 37 to 43 odd. The same number of questions, but one of them is a little more difficult. On page 253. So 9 to 19 odd, 25 and 27, 37 through 43 odd, 253.